Srinivasa Ramanujan was born on the 22nd of December 1887 in Erode, Kumbakonam. Ramanujan was one of India's greatest mathematical geniuses. He made substantial contributions to the analytical theory of numbers and worked on elliptic functions, continued fractions, and infinite series. In 1911, Ramanujan published the first of his papers in the Journal of the Indian Mathematical Society. His genius slowly gained recognition, and in 1913 he began a correspondence with the British mathematician Godfrey H. Hardy that led to a special scholarship from the University of Madras and a grant from Trinity College, Cambridge. Hardy was a vital part in Ramanujan's life as he filled in the gaps in his mathematical education by private tutoring, and co-authored several papers with him before Ramanujan returned to India in 1919. In Ramanujan's final years, he was diagnosed with tuberculosis and a severe vitamin deficiency, which confined him to a sanatorium. In 1919, he returned to his hometown of Kumbakonam, and in 1920 he died at the age of 32. Ramanujan's most famous proof is his infamous summation of all positive integers, which equal -1 on 12. Initially, this summation may appear absurd, but his logic behind the process was actually very sound. Upon the reception of this proof, along with his other work, the renowned English mathematician Godfrey Hardy recognized the intelligence behind the proof, establishing Ramanujan's place at Cambridge University, where Godfrey was a professor. Ramanujan developed the circle method, which is the expression of an integer as two other integers, which is an essential piece of equipment in analytic number theory. Ramanujan's conjecture is another piece of information he has contributed to mathematics. It is currently being used to bridge the gap between representation theory and algebraic number theory through the Langlands program. The complexity of elliptic surfaces was overshadowed by Ramanujan's discovery of K3 surfaces, an important concept in string theory. He also developed the most rapidly converging formula to find pi, and was able to produce it accurately to over 100 million decimal places. Ramanujan had many mathematical influences throughout his brief career. Although most of his work involved infinite series and partitions, he still had a great impact on many fields of mathematics. For example, the Ramanujan-Peterson conjecture resulted in the famous Langlands project, which is regarded as the single largest project in modern mathematical research. His research into theta functions led to a range of unique discoveries. Just one of these is his creation of the first mock modular forms, which are being used to calculate the entropy of black holes almost 100 years after his passing. Ramanujan is considered to be significant because of his numerous contributions to mathematics solving or providing helpful theorems for problems that were considered to be unsolvable. Ramanujan's sum is used by other mathematicians to prove important results in number theory, and in recent years, engineers and physicists have found applications of this sum in digital signal processing. Due to Ramanujan's work in mathematics, he was elected into the Mathematics Society in 1917 and the Royal Society in 1918, as the second Indian to do so. Both of these groups were significant and still are today for their study of maths and science. Ramanujan has impacted maths today, as some of his work, which seemed inept at the time, has been very helpful for modern problems.